we have seen the harmonic function, and then how to find the harmonic conjugate of the function using Milne-Thompson method. Now we have to see another concept, okay, related to the analytic function. Okay, so that concept we have the orthogonal trajectories. Okay, so now we have to consider the orthogonal trajectories. So in orthogonal trajectories, again, we have that f of z is equal to u plus iv p, and analytic function. Yeah. Then we have u is equal to c1 and v is equal to c2 are orthogonal trajectories of each other. Okay, so that means u is equal to c1 is orthogonal trajectory of u is v is equal to c2. Okay, and we can say this is now the family of the curves. Okay, so this is one family of the curve that we have, and this is the another family of the curve that we have. Okay, and if this function f of z is analytic, then we say these two are the orthogonal trajectories of each other. Now the question is how we are able to find out this orthogonal trajectories. So to find orthogonal trajectories, we consider the following steps. Okay, so what are the steps that we consider? Okay, so let us write down that steps. Okay, so I hope you are writing with me. So I hope you are done with this. So are you done with this? Yes. Okay. So no problem. That's what we'll have. Okay. So if you are done with this, we'll go with the another. So we'll write this 5 steps. Okay. So what are the steps we have to consider here? So for orthogonal trajectories, as we know, we have to go through the analytic function again. Okay. So we'll see the steps to find orthogonal trajectories. Okay. So what are the steps here? First step we have to consider, right? F of z is equal to u plus iv t, and analytic function with the given real part or imaginary part with real part u and imaginary part. Okay. So now what we have to do is use Milne-Thompson method and find the analytic function f of z. Okay, and the third step, okay, put z is equal to x plus iy in f of z and separate real and imaginary parts. Okay, so here you can see these steps are exactly same as we have for the harmonic conjugate. Okay, but here we are going to find the orthogonal trajectories. Okay, so here we have to find the orthogonal trajectories. And once we know that u is equal to constant and v is equal to constant, so the u is a family of curves which is orthogonal trajectory of family of curves v is equal to constant. Okay, so these are the steps that we have to use. I hope you have written this. Are you done with this? Yes. Okay. So if you are done with this, then we can have the example based on this. Okay. So let's have the example based on this. Okay. So we'll have the example. So write on the example. Find the orthogonal trajectories your example, find the orthogonal trajectories of the family of curves. Okay, so what is the family of curves given? X cube y minus xy cube is equal to c. Okay, so here this is the family of curves given, and we have to find out the orthogonal trajectory of this family of curves. Okay, now we have to be careful. Okay, so here it is neither mentioned that this is u nor mentioned that this is v. Okay, then how to proceed? So we can consider this as a u also or this as a v also. Okay, so let us consider this as u. So what I'll do is I'll write the first step. Let f of z is equal to u plus iv p and analytic function with real part u is equal to x cube y minus xy cube is equal to c. So now in this example, we have to be careful that c is going to be the given constant. Okay, and hence we cannot use this c onwards. Okay, so the first step for the Milne-Thompson method is this one. And now what we can do is consider the second step. So what you'll be having, as there is a real part, phi 1 of xy is equal to w by w x. And here this is going to be 3x square y minus y cube. So we have the derivative, and we can have phi 2 of xy is equal to w by w v by w y. So what we have here, this w by w y. So if I want to find out the derivative of this, what you'll have is, we'll have x cube minus 3xy square. So that is the derivative we have. Now we have to consider the next step. So what we have to do is, we have to put x is equal to z and y is equal to 0. So you tell me, are you done with this? So have you written this one? Okay, that's good. Okay, so let us go for the third step then. Okay. So what we have, the third step now. Okay, so we have here, what we'll do is put x is equal to z and y is equal to 0. We consider this as equation 1 and this as equation 2. Yes. So in equations 1 and 2. Okay. So we get, what we are able to get is, see, phi 1 of z0 is equal to. So if I put here x is equal to z and y is equal to 0, then this term goes 0. And if I consider in terms of phi 2, so phi 2 at z0 is equal to. So if you put this as z and this as y is equal to 0, so it will become z cube. And here we have this term is equal to 0. Okay, so we got the third step of the Milne-Thompson method completed. And now we have to consider the fourth step. Okay, so what is the fourth step we have? See, okay, so we can write by Milne-Thompson method. Again, the analytic function f of z, okay, is given as. So what is the formula for f of z? So we have f of z is equal to integration phi1 of z0 dz minus I integration phi2. And so we have integration phi2 of z0 dz plus now here we cannot use c because c is given to us. So we use c1. Okay, and where we write where c1 is constant of integration. So this is going to be the constant of integration. Okay. Now we have phi1 of z0 is 0, phi2 of z0 is z cube. So we can write here f of z is equal to integral 0 dz. Okay. Here we have this is minus I constant of integration. This is minus I integration phi 2. So we have z cube dz plus c1. Okay, and now we have to evaluate this integral. Okay, so you please write if you are done, then we'll go for the next step. So if you are done, then we'll go for the next step. Okay, so I hope you are done. Yeah, let's go for the next step. So what we have, the next step here, we have to evaluate, and hence we get f of z is equal to. Okay, so we are having here this minus I z raised to 4 by 4 plus c1. Okay, so this is going to be the analytic function. So this is the analytic function that we have. Okay, so we can say is the required analytic function. Okay, but here in this case we are not interested in analytic function. We are interested in orthogonal trajectories, and hence if we are interested in orthogonal trajectories, we have to find its real and imaginary part. So what we can do is put z is equal to x plus iy in above equation. So we have, okay, what we are having here. See this f of z equal to, okay, so I'll be having minus I by 4 and I'll be having h plus iy bracket raised to 4 plus c1. So we have to find the expansion of this term, and what we have, this is minus I by 4. You have here, see, this will be x raised to 4 plus 4 x cube iy plus 6 x square iy square plus 4 x iy cube and plus iy raised to 4 plus c1. Okay, so this is what we'll have the expression. Now let us simplify this expression. So what we know is, we know I square is equal to minus 1, I cube is equal to minus I, and I raised to 4 is equal to 1. Okay. So that's what we have. Okay. And hence we have to use this. So what we know is, we know I square is equal to minus 1, I cube is equal to minus I, and I raised to 4 is equal to 1. So we have to use this and simplify this expression. Okay, so let us use it and simplify this expression. So are you done with this? Have you written these equations? Okay. Good. Now let us see the remaining. Okay. So what we have here, we have to simplify this. Okay. So let's have this. We have f of z is equal to minus I by 4. So we have x raised to 4. Here I'll be having, see this term, plus 4i x cube y plus this I square will become minus 1. So I can have this as minus 10. So this will be minus 6x square y square. And then I have here, this will be I cube. So it is minus I 4 xy cube. And this term is going to be 1. So y raised to 4 plus c. Okay, so that's what we got here. Now, simplify this. Okay, so we have here, this is equal to. Now, if I multiply by I by 4, I'll multiply this by I by 4. So we can have equal to, this is minus I x raised to 4 by 4. Here I'll be having minus this 4 will get cancelled. I square x cube y minus minus plus 6i x square y square by 4. This minus and this minus will become plus, and we'll be having 4i square. This 4 and this 4 will get cancelled. So we can write directly only I square xy cube. This time we have minus I y raised to 4 by 4 and plus c1. So this is f of z. Now if we simplify more, we are having f of z is equal to, see, this I square is minus 1, so this minus 1 will become plus. So you got x cube y minus this term I square is going to be minus 1. So xy cube plus I we can have outside. So if I take this I outside, what I'll get is, I'll have I by 4 outside. So I get here 6 x square y square. From here I have taken I by 4 common, minus x raised to 4. So from here I have taken I by 4 common, so minus y raised to 4 and plus c1. Again, so here what we got is, we got a real part and we got imaginary part, and you can see exactly this is u. Okay, what was given to us. Okay, but here we are not interested in V, but we are interested in family of the curves. Okay, so what we can have is, hence we can say comparing real and imaginary parts we get. So what we are able to get here, see, u is equal to, this is our u, so x cube minus xy cube, and v is equal to I by 4 6 x square y square minus x raised to 4 minus y raised to 4. Okay, but we are interested in the family of curve. So if I compare this, yeah, here I can omit to write this I. Okay, so I can write this 1 by 4. So if we want a family of curves, so if I compare this equal to constant, then it becomes family. So here this equal to constant will become a family. Okay, so if you are done with this, then tell me, we'll write the orthogonal trajectories. Okay, so are you, if you are done, then tell me. Yeah, okay, that's great. Okay, no problem. So we'll, we'll write the family of curves. Okay, and here, hence after this, we can write, so the orthogonal trajectories. Once we have separated the real and imaginary part, we are able to write the orthogonal trajectories. Okay, so here our final answer should be like this: the orthogonal trajectories of the given family of curves is. So what you'll be having here, this is being a constant, we can take care in terms of constant. So you'll be having 6x square y square minus x raised to 4 minus y raised to 4 is equal to another constant. So this all is by 1 by 4. So that 4 I can take and I can merge it with this constant. So if I consider this as a C 2 and then multiply by 4, then again it will be a constant. And this way we are able to find the orthogonal trajectories for the given family of curves. Okay, so this will be the final answer that you will have. So are you done with this? Do we have any doubt in this example? Okay, so it is very much similar to the harmonic conjugate. Okay, it is very much similar to the harmonic conjugate that we have seen. Okay, and if we know harmonic conjugate, it is easy to calculate the orthogonal trajectories. Okay, so that's why the every time we are using Milne-Thompson method to use this or to find the analytic function, and we are able to find the orthogonal trajectories using this again. Okay, so let us have another example. Okay, we can think of another example. Okay, So let us see the another example based on this. Okay. So we'll have one more example. So write down the example. Find the orthogonal trajectories. Find the orthogonal trajectories of family of curves dx square y plus 2x square minus minus y cube and minus 2y square equal to constant. So here we have to find the orthogonal trajectories for this family of curves. Okay, so let's have this. So let f of z is equal to u plus iv be an analytic function. So this will be an analytic function with. Now I have said that this either you can consider u, either you can consider v. So that doesn't matter. So analytic function with real part u is equal to dx square y plus 2x square minus y cube minus 2y square is equal to c. Okay, and then so what we have to do the next? We have to find the first order derivatives. So what we do is consider I1 of xy is equal to w by wx. So here we have 6xy plus we have 4x. The derivative of these two terms will be 0. And we have, let this equation 1. And we have phi 2 of xy, that is w by wy. So here we have to consider with respect to y. And hence we have here 3x square. The derivative of this term will be 0. Now minus 3y square. And here this will be minus 4y. So let this equation 2. Now if we want to find out the analytic function using Milne-Thompson method. So here we have completed the first step. Here we have completed the second step. Now we have to go to the third step. What we have to do in the third step? We have to put x is equal to z and y is equal to 0. Okay. So if you have done this, then we'll go for the. So are you done up to this? Okay. That's good. Okay. So let us see the remaining part. Okay. So we have to put x is equal to z and y is equal to 0. Okay. So let's have it here. So we put, okay, here the next step we have x is equal to z and y is equal to 0 in equations 1 and 2, and hence we have, okay, so what I'll be having, phi1 of z0 is equal to, so what is phi1 of z0? So this is going to be 0, this is going to be 4z, and we have phi2 of z0. So phi2 of z0, this will be the term 3z square, and these two terms will be 0. So this way we are able to get the phi1 at z0 and phi2 at z0. Now we got phi1 and phi2 at z0. Next, what we have to do is, this is the third step of the Milne-Thompson method we have completed. Now we have to go for the fourth step. Okay, so we'll have hence by Milne-Thompson method. Okay, the analytic function f of z is given as. So what will have f of z? So f of z is equal to integration phi1 of z0 dz minus I integration phi2 of z0 dz and plus c1. Okay, remember here that we have already used c, so that's why we are using c1. Okay, where c1 is constant of integration. This is going to be the constant of integration. Okay, now we write what we have f of z. F of z is equal to, here we have, okay, so this is 4z. So we have 4z dz minus I. Then we have here dz square dz plus c. Okay, so if you can simplify, this will be 4z square by 2 minus I dz cube by 3 plus c1. So we can write here f of z is equal to 2z square minus I z cube plus c. Okay, so I hope you are able to get this one. So are you done with this? So you are done with this? Good. Okay, now let us separate the real and imaginary part of this function, whatever we have obtained. Okay, and hence we have, okay, so we have to separate the real and imaginary part of this. So let us separate the real and imaginary part of this function. Okay, so we have calculated here that this is the analytic function. Okay, and now we have to find real part and imaginary part. So we have the analytic f of z is equal to 2z square minus I z cube plus c. So what we can do is put z is equal to x plus iy. We get, so what you'll get here, f of z is equal to x plus iy bracket square minus I. Okay, so we have here minus I, and this is x plus iy bracket cube plus c. Okay, so let us simplify. Uh, let us write the expansion of this. So we got This is equal to the expansion of this we have x square minus y square plus 2ixy. So here we have 2. So this is 2 times. Now minus I. Now the expansion of this, so you will be having x cube plus 3I x square y minus 3x y square minus iy cube and plus c. Simplify this. So we have 2x square minus y square plus 4ixy. Now multiply by this. So we can have minus I x cube minus 3xy square. And here, if I multiply by this minus, so I'll be having this I square we have minus and already minus. So plus 3x square y. In this case, we have minus minus, and so this will be minus y cube. Okay, because already we have minus, this minus will become plus, and I square we have, so I square will be again minus, and plus this c. Okay, so now what we get here? So we get f of z is equal to c. I'll have 3x square y plus 2x square minus 2y square minus y cube. Okay. So we have minus y cube. This is the real part. Okay. Imaginary part, what we have here? This is plus I 4xy. Then this minus I have to take inside. So minus x cube plus 3xy square plus c. Okay. So this way we are able to get f of z. And now we have to compare the real and imaginary part. Okay, so if you are done up to this, then tell me. So are you done up to this? Okay, okay, that's good. Now we have to separate the real and imaginary part. Okay, and hence what we can have is we have the function f of z, and now if we separate the real and imaginary part, we'll get u and v. Okay, so we have to separate this real and imaginary part. Let us separate the real and imaginary part. Okay, and hence what we have is comparing real and imaginary parts we get. Okay, so what we are able to get is see here we get u is equal to 3x square y plus 2x square minus 2y square minus y cube, and we have b is equal to 4xy minus x cube plus 3xy square. Okay, so that's what the terms we have. Now see, we are interested in writing the orthogonal trajectories. Okay, so here we have the real and imaginary part, and if we are able to get the real part properly, that means we are able to get the imaginary part in proper way. And hence, what we can say is, so the orthogonal trajectories of the given family of curves is what will be having 4xy minus x cube plus 3xy square is equal to the another one. Okay, so this way we are able to get the orthogonal trajectory for this given graph. Okay, so are you able to get this one? Are you done with this? Are you done with this? So do you have any doubt up to this in these two examples? What we have solved?
No, sir.
No doubt. Okay, that's great. Okay, so that's good. We'll solve one more example. Okay. Okay. So here, write on the example. Find the orthogonal trajectories. Find the orthogonal trajectories for the family of curves Pxy. For Pxy, we'll have 6xy is equal to 0. Okay. So easy. So the solution, right? What you can have is P of f of z is equal to u plus ib, p, and analytic function with real part u is equal to 6xy is equal to 0. Okay. So the second step, what we have is consider the first order derivative. So what we have y1 of xy is equal to w by wx. So it is 6y. This one, and y2 of xy is w by wy equal to 6x. That is equation. Now what we have to do is put x is equal to z and y is equal to 0. Okay. So are you able to get up to this one? Are you done up to this one? Yes. Okay. So we can have then what we'll do is we'll put x is equal to z and y is equal to 0 in equation 1 and 2. Okay. So let us put x is equal to 1 and y is equal to 0 in equation 1 and 2. Okay. So put x is equal to z and y is equal to 0 in equations 1 and 2. We get, okay. So what we'll get is y1 of z0 is equal to 0 and y2 of z0 is equal to 6z. So once you got this phi1 and phi2, we are able to use Milne-Thompson method. So we can say by Milne-Thompson method, the analytic function f of z is given as. So what do you have f of z? F of z is equal to integration phi 1 of z0 dz minus I integration phi 2 of z0 dz plus c1, where c1 is constant of integration. Okay, so we get here f of z is equal to, so it is 0 dz minus I integration 6z square z dz. Okay, so what we get here dz plus c1. Okay, now are you done up to this one? So this is equal to 0 minus I. We have 6z square by 2. Okay, so here we get 6z square by 2 plus c1. So are you done up to this? Are you able to get up to this one?
Yes, sir.
Okay. So now let us simplify the remaining. Okay. So we have we get f of z as, so we have f of z is equal to minus 3I z square plus c1. So is the analytic function, and hence once we get the analytic function, what we have to do is, so put z is equal to x plus iy in above equation. Hence we have, so what we'll be having here in this case, f of z is equal to minus 3I. So we have here minus 3I, and it is x plus iy bracket square. So minus plus, here we have to be careful that plus c1 we must write plus c1. So this is minus 3I x square minus y square plus 2I xy and plus c1. So we get here, so this is going to be 6xy. Okay, and this term what we can have is, see, minus I am absorbing inside, so I'll be having plus I, and here we have 3y square minus 3x square plus c. Okay, so once we get this, then we have to compare the real and imaginary parts. Okay, so this is f of z, and hence we can write comparing real and imaginary parts. We get, okay, so what we'll get is u is equal to 6xy and b is equal to 3y square minus 3x square. So here we are able to get the real and imaginary part, and now we have to write the orthogonal trajectories. So are you able to get up to this one? Are you able to get up to this one? Yeah, that's good. Now let us write the final answer. Okay, so we have the final answer as, so here we can write the orthogonal trajectories. of given family of curves is what you have here, 3y square minus 3x square is equal to the constant. So this constant will generate the family of curves. So that's why we have to be careful. We should always write the constant because that is going to be generate the family of curves. Okay, and hence when you write constant, it will be family of curves. If you do not write constant, then it will be only one curve. Okay, so that's how we are able to get the orthogonal trajectories. Okay, so do you have any doubt in these examples we have solved?
No, sir, no doubts.
Okay, so that's good. Okay, you don't have any doubt.